Hello. Awesome. Hello, folks. I see people jumping in here. Good afternoon, good morning, depending on where you are. We'll give it a minute or two while people file in. Hello, folks. Big shout out to anybody who joined us live we had a fun event in New York last night. If anybody joined us live there, welcome back. And we'll have some stuff upcoming too that I'll talk about in a little bit. We'll give it one more minute and then get things started 2 or 3 minutes past. Okay, we can probably, I see some folks have jumped in here. We can probably kick things off. Just me today for the paper reading, so you guys will be hearing my voice more than usual on these things, but we've got a fun paper to go through. The one we're going to talk through is called Agent as a Judge. I will dive into that in 1 second, but just as a quick intro for anyone who hasn't joined one of these before, these are a series that we do every week where we will take a paper that's been either recently released or has recently kind of come to the forefront in some way, and we'll kind of deconstruct it, go through it, share some of our takes on it, and talk through the details. I'm excited for this one today because this one actually is about a month old and has some cool implications. So I'm excited to dive into the Agent as a Judge paper that we're going to go through here. My name is John. I'm one of our developer advocates and growth engineers here at Arise. So I get to focus a lot on a little bit of our R&D, a little bit of our kind of technical testing of new tools and new frameworks and things like that, and then a lot of our kind of events and technical content that we put out into the world. So excited to be here with you all today. Um, yeah, and with that, let's jump in. So we'll go through here. Actually, I should say as well, if you guys have questions or comments throughout, feel free to drop them in the chat. We will have um, we'll go through that material as they come up. I see somebody in the chat already. So that you have not missed anything, we're about to jump in right now. We're just getting started right now. So you are perfectly on time. Awesome. So the paper we're going to go through, I mentioned, is called Agent as a Judge. It was published about a month ago, so it's relatively new still, mainly from a team out of Meta. I've got a QR code here if you want to see the paper, read along. It's also linked in the links that we have below in Zoom here, so if you want to take a look there, you can. And the Agent as a Judge paper here, it introduces two main things. One is the idea of using an agent as a judge as opposed to kind of a traditional LLM as a judge. So they introduce a framework for that kind of approach. And then they also go through and release a data set that they use for benchmarking agentic tasks. So we'll kind of talk through both of those because one leads into another. And they're both kind of interesting things to talk through. So the main kind of issue that they talk about, the authors put forward as the reason that they're tackling this topic is because they believe that contemporary evaluation techniques focus exclusively on final outcomes or require extensive manual labor, which makes them not really work for agents or for judging agents. And so if you think about the way that agents are kind of judged today, typically it's either done through using an LLM as a judge technique, which if you joined some of our previous material or you've used Arise before, or you kind of just been following the space, you might have seen LLM as a judge, but the core idea there is using an LLM, a separate LLM to judge the performance of your application, your LLM-based application. So you're kind of taking a separate judge LLM and you're using that to judge your AI app. And so that what the authors are kind of putting forward here is that that technique, I think the first section here, the exclusively focused on final outcomes piece, is kind of targeting LLM as a judge and saying, hey, if you just look at the inputs and outputs from runs of your application and try to judge just those sort of inputs and outputs themselves, you're missing what happens in between, which you could also evaluate. So I think they're kind of making a little bit of a poke at LLM as a judge there. And then the requires extensive manual labor piece is more kind of pointed towards human evaluation and human labeling and things like that, which is obviously a technique that's still used to judge models in some cases and judge applications built on top of models. So the authors are trying to kind of put forward this new agent technique as a way to address some of those concerns with what they see of traditional. I like saying traditional evaluation techniques, even though we're only like a few years old max at this point. But yeah. So I'm going to go through a little bit of the benchmarking data set that they create to kind of show and test some of their agent as a judge piece here. So I'm going to go through this benchmarking data set first, and then we'll talk about the agent as a judge framework that they institute, because there is sort of a story through those two. Um, but yeah, so the authors start by putting forward this DevAI benchmarking data set. They're calling it DevAI. And this is a data set of 55 real world kind of AI app development tasks. So it's code generation tasks. Like that's what the sort of core job that's being done in each one of them is. And we'll go through some examples of what the tasks are, but it's things like writing code to hide text in an image or something along those lines. So it's kind of generally complex real world tasks that you might ask an AI to do and to generate code to do. And so they've created these tasks. And part of their motivation behind creating these, as they say in the paper, is because traditional kind of benchmarking data sets that they have are they don't believe are like accurately representing what happens in the real world. They think they're a little bit like too narrow in the case of SweBench or Human Eval, which are some of the more popular kind of code gen evaluation data sets. And then they also kind of highlight one of their concerns from before, which is for things like MLE Bench, which is OpenAI's put forward benchmarking data set there, doesn't include intermediate steps. So if you're asking a model to do code generation over kind of a full kind of task where they might have to do multiple steps of code generation or multiple steps to retrieve information before they do that code generation, they're arguing that most data sets today don't account for that and just look at the outputs, for example. And so with their DevAI benchmarking data set, their whole idea is that they want to kind of use practical real world scenarios and they want to have the full development cycle be something that is kind of evaluated and processed here. So that's their reasoning behind creating this DevAI benchmarking data set. This is a visualization they have of the actual data set itself. I think they show a few things here, but just to kind of reiterate, one is that when you look at the types of tasks that are being put forward, it's things like supervised learning, task classification, kind of traditional AI coding tasks that you might have to do. And then you see they're using a bunch of different models and things like that that are being mentioned here. So let's show an example of what one of these tasks look like, because I think that helps make it a little bit more concrete in terms of what each one is. So this is one of the 55 examples that they have in the benchmarking data set. And so basically it's a query from a user where they're asking some code to be generated here with some requirements and then some preferences. So this example, it's following instructions on this blog post to set up a script for hiding images and text, like generating images with hidden text inside them. And then they have a couple of requirements here of the resolution and then saving the results into this results directory. And then they have a few kind of preferences as well that are laid out below. And so each of the 55 examples that they have and 55 kind of test cases also has a set of requirements that have to be met and has a set of preferences that can be met, and they kind of get bonus points for meeting. And so the whole idea is that you can run agents through these inputs and see what kind of output they get to. And then you can check with this benchmarking data set to see if the requirements have been met, see the preferences have been met to score it from there. And so what they then do in the paper is they've created this benchmarking data set. They then take three different popular code generation and coding agents, MetaGPT, GPT Pilot, and OpenHands. And then the authors basically run each of those model or each of those agents powered by a GPT 4.0 checkpoint over their whole benchmarking data set. And so they basically test the performance of each of these coding agents and some of these ones that have been put forward. And so there's some metrics here that are somewhat interesting around like the cost for each one and the time used and things like that. I'll let people dive more into this in the paper if you're really curious about the like the token usage, the time, and everything like that. They have a little bit of info there. But I think what's a little bit more interesting is the actual performance of these models or of these agents, excuse me, on this benchmarking data set. And so there we have a couple different pieces that are called out here. One is they have independent requirements, which is this first row I. So it's does it meet the requirements of does the solution put forward by the agent meet the requirements of the task that was put forward? So does the solution meet all of these R0 through R2 for that particular example? And then you also have dependent requirements, which are kind of more difficult. And in some cases, you have cases where the model might be, or the agent might be asked to generate multiple different code snippets and things like that that are dependent on previous rounds of generation. So more kind of real world, where you're going to say this has to work with a previous example, for example. And in that case, you can see the models generally perform worse on those, or excuse me, the agents generally perform worse on those. Even kind of your top end ones here are still maxing out at only about like 28, 27% success rate of incorporating those requirements. And then you see things like MetaGPT falls off a lot there as well too. So the dependent ones are definitely the more difficult piece, but you can kind of think of these two top metrics as the sort of general success rate of each of these agents on their benchmarking data set. So it's definitely a difficult data set to complete. And I think it's always good when people put forward these data sets because as you have things like Sweetbench and other ones that are that have been around for a little while now, you start to get models that are trained on those data sets, and then they obviously do better. But then when they go and incorporate real world examples, they might do worse there. So I think this is an interesting slice here where you have a new data set that's been generated and they're testing it on these existing agents. So it's kind of as close to real world examples as you could get in this first round of testing that they've done. And it is a difficult benchmark that they've set here. So now that they have the Dev AI benchmarking results from these three popular agents that are being used, what they do from there is they basically try to add in human evaluation and essentially judge the quality of the human evaluation. So I'll kind of talk about what they do here, but basically what they end up doing is they take three different human judges and they refer to those as, in this case, 2231A, 38BB, and then CN90. Those are all people. Those are all like humans that evaluate the data. And they have each of those humans evaluate each of the 55 runs of, or I guess actually it would be in this case, 165 runs because you have three different agents running on 55 examples. So they have each human evaluate each of those different runs and kind of score the requirements met or the success rate from there. And then they can compare those human labels to the original benchmarks for the data set itself and see how off the humans are from that original kind of benchmark that they have. And so what they saw was that the humans judges individually had an error rate of up to like 23 or 24%. So you can see in this error rate kind of comparison here, you can see CN90, for example, was like the least aligned judge. And they were off by almost as much as 24% in some of their judging. Goes down a bit depending on who the judge is. Some are more judicious than others, and some are kind of better at judging. But you see that the humans can still have a pretty high error rate when they're assessing whether or not these agents passed their benchmark. And then even between the humans, you have a huge amount of disagreement. So the graphs at the top here are essentially measuring the disagreement rate between different human judges. So this is how much 231A disagreed with 38BB across each of the different agents that they tested. And so you can see the disagreement rates ranging from 10 to 35%, especially when you incorporate all three of them. So I guess the core message there is that human judges will disagree a lot too. So you start to get to a lot more alignment among the human judges and kind of get them closer to what the like truly right answer is when you do a majority vote, which is this bottom row here in our little error rate comparison. So it kind of proves an old thing that we already knew, which is that if you actually have human judges and then you take the majority of their opinions, basically like for each one you have them do a majority vote on success or failure, they're going to align more closely with what we believe is the true answer, which makes sense because oftentimes what we believe is the true answer is actually from that majority voting kind of process. So I think when they're judging this human judging process itself, I think the kind of core takeaways here are that as they pointed humans towards this, there was disagreement among the humans. The humans could be wrong. And a lot of it came down to just the difference in opinions of those particular human judges, which gets smoothed out by the majority vote approach that they use. The other kind of call out to make here is that they measure the time taken as well for this, and it takes a total of 86 and a half human hours to do this whole labeling process because they initially have the judges label each row, and then they have them come together and debate and kind of come up with their eventual like majority recommendation. So it took them 86 and a half hours of people time to do this. And so you probably see where this is going now, where they're saying, now the big question, they've kind of laid out the scenario and they've used this benchmarking data set. And now they're going to say, okay, can we replace these human judges with an agent? Can we replace the job they're doing of deciding whether or not each of these agents pass the benchmark? Can we replace that with another agent? And will that be better or will that be worse? And so this is where we get into agent as a judge, which is the technique that they put forward. And so with agent as a judge, what they started with is they built an agent that had 8 different skills here, and 8 different kind of nodes that it could do. So this is the kind of structure of the agent that you see here on the right. And so they have these 8 different nodes. They had a graph node, which will build a graph of the sort of required task and say, okay, this is what we need to do, and this is the different kind of flows that we're going to go through. And then it has a location skill or a locate skill, which is going to identify folders and files specified by the requirements of that task. So if you think all the way back to our example task, this basically identifies the results directory and it identifies the files that need to be used there to judge. And so we have the locate skill. Then there's a read skill, which is kind of reading in those files, understanding the data. And I should note I'm simplifying a lot of like what each of these different steps do. But for the read one, for example, it's like a much more complicated step that can handle unstructured data and all this other kind of fancy stuff. But basically, it's just reading in information from the files and the output files from that round of the run. And then the search function or the search skill that it has will go through the code generated by the agent and it will search for the most important snippets, the most relevant snippets that the evaluator agent here will go in and try to evaluate. And then there's a retrieval step to just pull info from long pieces of text. There's an ask step, which is checking to see whether the requirements are completed and satisfied. And then they also incorporate a memory stage here, a memory skill, where the agent will remember its judgment on previous runs and previous tasks, so that it can have kind of consistency in judgment and can store the historical data there. And then finally, they have a planning step, which is to plan the whole kind of process of how this agent is going to execute. So this is their first draft, basically, of what is the agent as a judge, like the judge agent going to look like. This is the first draft that they put forward into the world. And they test it out, they try a bunch of different things. And what they actually find is that a few of the steps that they incorporated are actually hurting the performance of the agent more than they're helping it. And so what they come to is that they actually end up taking out search, memory, and planning, and they just leave the 5 bolded steps that you see there. So what they were finding was that search, for example, was actually like making the agent performance worse, which sort of makes sense because most of these examples are 100 lines of code that have been generated here, or they're sort of short amounts of code. And so searching within that does more to like remove the stuff that you're looking at than it does to focus you, because most models are going to be fine focusing on 100 lines of code, for example. So search is something they actually pull out. And then memory and planning basically just add more noise that confuses the agent, is the way they put it, over time. So they end up removing those sorts of steps and those sorts of skills so that they just focus on the 5 that are bolded there. Uh, and there's some kind of fun analysis that they do in the paper where they basically like add in and remove a bunch of these different steps in their agent to see the performance. And so I pulled one of those graphics here where they kind of show the performance of adding each of the steps they ended up with. But if you want to look in the paper for more detail, they do a bunch of like ablation testing essentially to add in the different steps and test performance and try a bunch of different search algorithms and everything like that. So they go pretty deep in terms of figuring out that this actually is the best set of steps that the agent could do. And so now they have their judge agent, and they're going to point that towards the kind of previous runs through their benchmark data set that they had created earlier on, and then get to these results. And there's a ton on here. They have like one giant kind of results table. So I'm going to spend some time kind of talking through what each of these mean. But the headline that comes out of this is that the agent judge basically outperforms a typical LLM as a judge or LLM judge in almost every case. I think in every case, actually, in this chart. And then it kind of matches and fits right along with the alignment to the human, kind of our 3 independent human judges that we used. So if you look through in a little bit more detail, this first kind of chunk here is an LLM as a judge being used in kind of a black box setting where it just looks at the input to the agent, the output from the agent, and then it tries to judge based on that. And so you can see its alignment rate here to the ground truth labels that they have. So it's not great alignment. It's pretty low actually in some cases here, depending on which agent they're testing. And then they go from there to incorporating their judge agent to have the judge agent judge how good each of these agents are, again, in that black box setting. So they have them just look at the inputs and outputs from the agent. And you can see even that will boost the alignment with those ground truth labels. So just even still that black box kind of setting, the agent as a judge outperforms the LLM as a judge. And then they go into this, what they call the gray box version, where instead of just having access to the inputs and outputs of these agents, they have access to the inputs and some trajectory data as well as the outputs. So they kind of know the steps they took and things like that. And the LLM as a judge kind of boosts in some capacity, it goes down in one, still not showing great performance there, versus the agent as a judge boosts across the board, or almost across the board, basically here. So as they introduce that gray box version of this, the agent as a judge again outperforms the LLM as a judge. And I think what's interesting here as well too is that the agent as a judge falls kind of right in line with the humans that we have. So these are our three human judges again from before, 38BB CN90 and 231A. And so you see that the agent as a judge alignment rates there would not look out of place with the human ones. I think there are a few humans who beat them in certain areas on certain cases versus some that fall that don't do quite as well as them. I think CN90, I don't know what was happening with them, but they're kind of our least aligned to judge. And so they get beaten out every time, but the others at least beat the agent as a judge in one of the cases for the agents they evaluated. It's worth mentioning that the majority vote does still beat out the agent as a judge when you're looking at kind of these different judging options. So just based on the results that they have here, if you had to kind of rank the efficacy of each of these different techniques, having multiple human judges and then taking the majority vote of those human judges is still going to be the most kind of accurate aligned technique. But then barring that, using either this agent as a judge approach that they put forward or individual human or an individual human judge, you're going to have similar kind of results. It just sort of depends on how good your individual human judge is. And so agent as a judge kind of acts as a good alternative to that. And then below all those is going to be your LLM as a judge, based on the results of the paper that we're seeing here. So it does kind of show that the agent as a judge beats out LLM as a judge and is kind of right alongside those human evaluators. Um, and so, yeah, with that, I think a couple of like kind of takeaways and notes to dive into a little bit more detail here. One is again, so agent as a judge can perform a single LLM as a judge on some of these tasks. For some evaluations, LLM as a judge is a little too simplistic. I do want to kind of throw my own opinion and caveat in here, which is that the way that they outline LLM as a judge in the paper is just looking at the inputs and outputs of an agent and then making a judgment there. I think in practice, you can really use LLM as a judge to evaluate very specific parts of your agent executing. You could do a LLM as a judge just on your router function calling step, or you could do it on a specific skill or something like that. So I do think one caveat to keep in mind when going through the paper is, at least from my reading of it, they are kind of taking the worst, most simplistic version of LLM as a judge and comparing it to their agent as a judge. I think in practice, you can structure an LLM as a judge framework that could achieve, I don't know if it could achieve the same results, but I think it would do better than what they have in the paper for the LLM as a judge. So I do think you want to have that in mind as you're going through. And then the agent itself that they create is really specific to evaluating these code generation tasks. So it's very specifically set up to just evaluate this particular code generation for the benchmark that the authors also themselves created. So they can kind of make it very customized to that. But I do think it's still a very kind of promising result. And so the big question to me is, can you generalize what they did? Can you take the agent that they created for a judge agent? And can you generalize that to work across other kinds of evaluation tasks? Or at least can you generalize it to work well across other benchmarks and other things like that too? And I think you probably could. I think it's a fun area to experiment with a little bit more in detail. I guess the last kind of piece I would add on the takeaway front here is that I feel like a lot of times our paper readings get back to a simple question, which is like, what is an agent and what actually makes something an agent? Because I do think there's also a potential middle ground between LLM as a judge and agent as a judge, where you have an LLM as a judge, maybe you have a few that are looking at specific parts of your agent executing, but then you also equip them with some tools. You equip them with the ability to um, search over documents that are generated by the agent, for example, or you equip them with some things that kind of go all the way back to our different kind of steps here. I think some of these are tools that you could equip an LLM with, and a judge LLM with. And then you get into the fun question of like, does that make it an agent? And then does it become an agent as a judge at that point? But I think to leave you guys with something on our reading of the paper here, I think we're coming away pretty excited about the possibility of having these agent judges, but I think we need to see if this can kind of generalize more to other tasks and whether it actually would outperform a true LLM as a judge system that's been set up in a really kind of thoughtful way to evaluate different parts of the agent as you go through. Yeah, awesome. And yeah, with that, just a quicker one today, but any questions or any thoughts from any of the folks who have joined in here? Would love to hear any kind of any reactions or thoughts that people have as we go through. Awesome. John, I am glad to hear it. This was a kind of a complex one, so I appreciate that folks were following along as we get into agents judging agents and kind of this meta commentary on top of it. So great. Well, last thing I'll say here is we have a couple things that are upcoming, so stay tuned for future programming that we have here. We have our final round of our Agents in the Wild series next Tuesday. This has been a fun one we do. For the past Tuesdays, we've had enterprises come in and kind of demo and talk through their process of building real world agents that are out in the wild. So don't miss that next Tuesday that we have coming up. And then we also are in the midst of what we're doing as a Phoenix Community Challenge Month, where we've put forward a challenge to build an agent and trace it with Phoenix. And you can win either some custom Phoenix swag or we have a $1,500 prize that we've put forward for the best one that we're seeing there. So we can drop some links for those either here in the Zoom or in the follow-up. And so definitely don't miss those coming up over the next few weeks here. And with that, thank you, everybody. I appreciate everybody's attention for this little bit faster paper reading that we had today.